Hello everyone. Today I'm going to discuss about series combination of resistors. And this is the question basically asked for 3 marks. And I know the numericals also important from this topic. So we'll see this, the step by step. Okay, let me start this with the diagram. Okay, here is the one resistor is connected, which is connected to one more resistor. Here are the three resistors are connected. Let me call them as a R1, R2 and R3 are the three resistors. Okay, let me call this as a point A, and here is the point B and point C and the point D. Okay, which is basically connected to a external source. Which is basically considered as a power supply here. All right. Okay. So what is series combination? What is series connection? When the resistors are connected to end to end, then we will call it as a series combination when the resistors are connected end to end. For example, the B end. Okay, here B is connected to the second resistor R2. R2 is connected to the R3. So in this way, each and every resistor is connected to end. Then these kind of combination or connections are called as series combinations. Okay, in series combination, we should observe few things. First point is same current flows through each of the resistor. Flows through the each of resistor. And second one is the total potential difference across the combination is equal to the sum of sum of potential difference across each resistor. Here the first point we can see that the same current which is flowed through the each resistor and the total potential which is applied here is V. Okay. Across the combination is equal to the sum of the potential across each resistor. So here the potential is going to be divided across each resistor. So let me call it as, okay, here is the potential is taken as V1 and across R2 the potential is V2, across R3 the potential is V3. Okay, so basically the total potential applied is V and the same potential is going to divide it into V1, V2, V3 across R1, R2, R3. And the current which passes through the circuit is taken as I. Okay, that is the total current passes through each resistor and it is the same current. Okay, now what I can do is let us consider let us consider three resistors R1, comma R2, comma R3 connected in series. Where V be the total potential difference across the combination. Correct? I be the main current passes through the resistors. Then V1, comma V2, comma V3 are the potential difference across each resistor. Correct? So now we can write it as V equals V1 plus V2 plus V3. This is the total potential, right? So let me call it as the equation number 1. So here in the diagram, we can see that V1, V2, V3 will be equal to the total potential connected. Okay, so I can say that, so V equals V1 plus V2 plus V3. That is taken as equation number 1. But from Ohm's law, we can write V1 equals what? I R1. V2 equals I R3. V3 equals, sorry here, that is V3 equals I R3. Let me call it as the equation number 2 altogether. Okay, so or else you can make it as equation number 1, equation number 2, equation number 3. That is left to you. I mean sub equations, but let me call all together as the equation number 2. Now use equation 2 in 1. So V equals, okay, V1 plus V2 plus V3. But V1 is IR1. V2 equals IR2. V3 equals IR3. We'll put it there. IR1 plus IR2 plus IR3. Okay. Then V equals, here I all is taken as common. I is taken as a common out. Then I into R1 plus R2 plus R3. Now, instead of connecting the three resistors, individually, so what I'm going to do is, here we are going to connect the three resistor as a single. Okay, that we will call it as the equivalent resistors. Okay, so instead of connecting three resistors R1, R2, R3 to end, I'll connect a single resistor which will do the function of the three all together at once. Okay, so let me draw the circuit diagram for the same. Okay, this is called as RS. Okay, this is the main current I. Okay, resistors in series. Okay, here is the potential supplied here. Same potential, but instead of connecting three resistors separately, I'm going to connect a single resistor, which will do the function of all three as one. Okay, so then RS be the equivalent resistance produces the same effect as produced by the combination of three. So now from Ohm's law, we know that V equals IRS. Okay, we'll call this as the equation number 3. We'll call it as a 4. Now use 4 in 3. So in this place, I'll write RS equals I into R1 plus R2 plus R3, where I and I can be cancelled out. Then we left out with RS equals R1 plus R2 plus R3. This is the general formula, an important formula used for series combination of resistors. Okay, so RS equals R1 plus R2 plus R3. Can call this as a star. It's important equations. Okay, so then let me conclude here. When a number of resistors are connected in series, the equivalent resistance RS is equal to the sum of the individual resistances. So when a number of resistors are connected in series, the equivalent resistance RS is equal to the sum of the individual resistances. Then I can say that RS equals R1 plus R2 plus R3. So again, I can conclude resistance are connected in series to get a higher effective value from lower values of resistances. So in series combination, the resistance will be higher. Okay, so all right. So thanks for watching. So if you have any doubt, you can put the comment. Okay, kindly share with your friends. Okay, kindly subscribe the channel. All right, so this is the important formula. We'll meet up in the next video. Thank you very much.